human beings, we're wired to be connected. From birth, we look for that connection. Where internet connectivity ends and a non-connected society exists, the desire exists to be connected. Once they find connectivity, this city starts to grow. It grows first from an educational perspective.
No longer can the top 3 goals of education be reading, writing, and arithmetic. Now I truly believe that they need to be relationships, relationships, relationships.
Exploration is not a bucket list where you simply check off places that you have been. You need to realize that you are in a frontier and there's always new discoveries to be made, oftentimes just by changing the way you make the observation.
You're exercising a muscle here every time you exercise empathy, and that's emotional intelligence. Continue that curiosity. Ask questions.
Because of that respect and my willingness to listen and his willingness to listen to me, he ended up leaving the Klan, and there's his robe right there.
This is the world we're playing with right now. And the reality is that we don't really know how it's going to look and what it's about.
So many people are looking for feeding their spiritual hunger. The human nature gap is real. The human nature gap is having ramifications.
What if we take an idea and then we embrace it, challenge our belief systems, challenge our perspectives? And today we're going to take one step beyond, and we're going to go that way and just seek new ideas.
Hello, and good evening. I am Arthur Zards. I am the founder and curator for TEDxNaperville. Looks like we're all good. Watching this video, it's bringing back memories. The last time we did a salon, it was right in the middle of the pandemic, and it's so refreshing that we're out of that, and it's bringing back a lot of memories. Thank you for joining us tonight. This is our first salon for TEDxNaperville for 2024. Last year, we kind of took a break just because the entire team, we kind of had to. And I just realized, this is our 15th year for TEDxNaperville, which I find fascinating. So welcome to our 15th year. I want to give you some quick updates before we start the salon with Dr. Jack Gilbert. The exciting news, save the date. This is going to be going out on an email at the end of this week. On April 25th, we are going to be doing a live in-person salon with our host sponsor, Nokia. And we're going to be doing it at the Nokia campus in Naperville. We're going to be doing the TEDxNaperville live salon, showcasing selected talks from the actual TED conference, similar to what we did last year. The bonus is Nokia is going to be putting together some food and beverages for the audience, and we're going to have 2 live speakers in a salon format who are going to be focusing on artificial intelligence. And the plan is to talk more about the human and ethical side of AI. So look for that on April 25th. We're going to be doing some adventures this year. We're planning one for the spring, summer, and fall. We have some volunteers working on that right now. And we are going to be doing back to our signature event, probably, the date's not confirmed, but probably the second week of November. So we're back. We're slowly getting back to the swing of things with a live in-person event, just like the old TEDxNaperville. For tonight, I do want to thank our sponsors. I want to thank the Lab Z, and I want to thank Cinema Group. Cinema Group is, if we're going to cut to Jonathan, the Cinema Group is run by Jonathan Ruff, who is part of the TEDxNaperville leadership team. And a number of years ago, he moved to Nashville Tennessee. So Jonathan, you want to drop into the feed real quick and say hello?
Hey, how's everybody?
And Jonathan's going to share something a little bit interesting. We're reminiscing about 3 years ago. I think that's the last salon we did. Was it like 3 years ago when we did Buddy's Place?
Yeah, I think that was the last salon we did.
And if anybody remembers, and Michelle, we might put it in the chat, if not now, a little bit later. We did a live salon. Jonathan moved to Nashville, and Buddy's Place was a guy who would bring in these aspiring young musicians to perform inside this guy's house. And Jonathan did a great job of organizing this live session from Nashville. And Jonathan, give us a quick update about these three singer-songwriters.
Okay, so there's like 4 pieces of exciting news out of it. So Buddy's Place is still going. They kind of worked their way through COVID. They've been doing it out at a ranch with about 100 people. They bring 3 singer-songwriters in. They've done 2 shows at a place called the Woolworth Theater, which for Nashville is a very famous place. It's where there were sit-ins during the 60s. And they actually did the show in there. He did his 100th show with 25 different musicians. And then the 3 musicians that performed for us that night, the singer-songwriters, Ryan Larkins. You can find Ryan Larkins on Instagram or whatever. He has just achieved his first #1 song as a songwriter with Cody Johnson, who, if you're a country music fan, you'll know who that is. I'll be honest, I'm not totally familiar with Cody, but that's a pretty big deal for Ryan. And then Ryan also has another song in the charts. Ryan is more of a country singer that is, I think, called The King of Country, off the top of my head. And then, so he's doing great. He's just really getting a breakout year. But it's kind of an amazing year for the other 2 as well. Paige Rose has been doing quite a number of shows in Nashville and around. And I know that she is just about to release an album. So if you go look for Paige Rose, you'll find her on Instagram, whatever. You also find her on Spotify. You'll be able to go and preload her album, and that will be coming out, I think, in the next month or so. And then Sean Kennedy, who's a fellow Brit from Scotland, although he's Scottish, so he would be calling me a Sassenach by now. In fact, he's become a good friend of mine. Sean is also in the throes of finalizing an album. I think he's got more songs than he needs for the album, so they're trying to figure out how to get there. His album releases sometime in April. He's doing a showcase here, and then he's hoping to do some touring dates. Certainly around Nashville, he's looking for some other venues, so maybe we'll get him to Chicago sometime. Arthur, so you can go see him live there, or maybe even out onto the West Coast where Jack is, and you can see him in San Diego. So that's the updates.
So that if Scott doesn't know that you called him a Brit. Well, the wonderful thing for the audience, and thank you so much, Jonathan, is Jonathan did a lot of time and effort to organize this. And the fact that you guys saw it first, the fact that we had 3 singer-songwriters that are aspiring in Nashville, all coming out with new albums 3 years later, is pretty exciting. So Jonathan did a good job of finding these young aspiring singer-songwriters. Before we get started, a couple of other quick announcements. We are looking for partners to help finance TEDx Naperville throughout the year and through our signature event. So if you are interested, go to our website, TEDxNaperville.com. There's a link for partners. We do need, we're 100% volunteer based. I'm a volunteer. Jonathan's a volunteer. Everybody you talk to, all the speakers are volunteers. Nobody gets paid. We do look for financial support, and we need volunteers. We started a volunteer push this year. The same thing on our website, TEDxNaperville.com. There's a link to participate or to volunteer. The key role that we need immediately is a volunteer coordinator. All of us have regular jobs, and a key resource is somebody that can help communicate and wrangle the volunteers so that they're all being communicated. So that's critical. So if you have good project people management skills, definitely drop us a line. We could use that person yesterday. And we are in the chat we are on LinkedIn and YouTube right now. The YouTube comments we can see. So if you have a question for Dr. Jack Gilbert throughout this interview or format, definitely drop it in the chat window. And if you want, with this new streaming technology, we have the ability where Jonathan can actually bring somebody into the stream to talk to Jack to ask a question one-on-one. So if you have a question, I think Jonathan has it here in the link. Just put "Ask Live" in your comment, and Jonathan's going to drop his. It's a little bit complicated. He's going to drop his email address, and if you email him your question, he's going to send you a link. And if you have a webcam and you're connected to the internet, which you obviously are, we're actually bringing you to the backstage. Think of this like as an old-time radio station, and then he's going to bring you into the stream so you can talk to Dr. Jack Gilbert live. It's just a fun way to play with the technology. There it is. And of course, his email is tokenbrit@gmail.com.
Hey, Arthur, just one quick point, just to correct. Yeah. LinkedIn and YouTube, we can see your comments. The issue is we cannot comment back on LinkedIn just because of the way the system works. You may see us commenting or pulling stuff out of YouTube more. But either way, we are reading all your comments. I actually have all of them coming up in front of me here on my screen. So we can see that. And as he said, if you send an email to tokenbrit@gmail.com, if you're interested, I will get the direct link out to you and we'll bring you into the studio. Okay?
Excellent. Thanks, Jonathan. And it's interesting. And the audience watching tonight, I just noticed there's a bunch of alumni speakers that are attending this salon too. So thank you guys for joining us. Okay, now we're going to get into our guests tonight. And to kick off, Jonathan's going to play a quick little video introduction of our guest today. He's a TEDx Naperville favorite of ours. I shouldn't say we have favorites, but Jack is. He's been with us for a long time. He's done a TEDx talk. He's done a salon in the past, and he's even sang an American blues song at one of our events. If anybody was there, they remember that special moment where you get Jack behind a microphone and some music. He's actually a quite accomplished singer. Let's start off with the introduction video, the 99-second video introduction.
The thing that gets me up in the morning is knowing that the work that we do could have profound implications for people that I love. My name is Jack Gilbert. I'm a microbial ecologist and a professor in departments of pediatrics and Scripps Institution of Oceanography at University of California, San Diego. I'm really interested in understanding how to stop virulent, dangerous bacteria from infecting people. When we were in the lab before, I was talking about 3 different projects, and they're quite different. So one of them, we actually collected bacteria on the International Space Station with one of our alums here from SIO, Megan MacArthur, who was an astronaut up there. She collected samples for us. We brought them down. We've been culturing them to grow up these bacteria. Another project was looking at creating biologically alive surfaces, functional ecosystems that can actually prevent pathogens from growing and disseminating and becoming more virulent in our homes. And the third project was looking at how bacteria grow on microplastics in the ocean, how those bacteria are getting inside shellfish and making those shellfish more likely to transmit human pathogens into our bodies to make us sick when we eat them. 38 million bacterial cells leave your body every hour, even if you're sitting down not doing anything. It's phenomenal. The common misconception is that you can somehow get rid of them. That's just not true. Instead of trying to eradicate this world, we're trying to work with it. We're trying to figure out how to be the best stewards of the microbial world so that we can manage that microbial garden and create it to improve the health of our planet and of ourselves.
Hello, Jack. Welcome, and thank you for being part of the TEDx Naperville Salon featuring you.
Hi, Arthur. How are you? Nice to see you again.
Before we get started, just since not everybody knows who you are, can you just do a quick little background of your ties to Naperville?
Yeah, so I was a professor of surgery at University of Chicago for about 10 years. And we lived in Naperville from around 2010 to about the middle of 2019. Before we moved out here to San Diego. So we have deep ties there, lots of good friends and good memories. Our kids grew up there. Owen Elementary School was our local elementary. My kids have fond memories of living in the neighborhood.
And what was your favorite restaurant bar that you'd always go to?
Oh, we always went to Sullivan's downtown. That was our go-to steakhouse when we were looking for something.
And I always tell people that as we go through this, as you start sharing the research, it just what I love about Naperville is that you might bump into somebody at Sullivan's and not knowing that, I think Time Magazine in 2015, you're one of the top scientists under 40 in the world, which is fascinating. I'm like, yeah, Naperville's not just soccer fields and good restaurants. There's amazing people like you. So I just want to share the Naperville ties because it's kind of cool to give a little bit of respect to Naperville. And so I want to start off by just asking you basic questions. You're going to kind of run the show, but I know you sent some visuals to us. We had that really neat animation. I don't know if you want to start off briefly with people that are new to the microbiology movement that you're involved with. If you just want to do a quick 2 or 3 minute setup from what before you start going deep on your research to give everybody a little bit of understanding about what the science that you're involved with.
Yeah, so I work to try and understand how microbes interact with each other. Those are bacteria, fungi, viruses, how they interact with each other in any environment, and how that interaction shapes the world around them. So inside your body, you have around 30 to 40 trillion microbial cells, right? And if you look at a teaspoon of seawater, you'll have around well, I don't know, like a million cells, right? And in a gram of soil, you'll have maybe a billion cells. So microbes are so prolific, their numbers are extraordinary. There are more microbes in the ocean than there are stars in the known universe, right? It's literally that big. And as it said in the video, we release, for these 40 trillion microbes living inside us, we release around 30 million of them into our immediate vicinity every hour. So just sitting here in my studio, I'm literally shedding my microbial biomass all over the environment. And if you go into a hotel room, for example, within about an hour of being in that hotel room and interacting with the hotel room, your microbiome will become dominant. It will become the only microbial signature I can identify in that room. I often think that's why people start living in a hotel room. They start interacting with the hotel room, and it feels very foreign. And then within a short period of time, we actually start to think of it as our room, and we become quite protective of it, right? I think it's because we have a microbial feedback loop with that environment that makes us feel like we're part of that space. Because literally we are now, right? We have left our microbial cells behind in that environment.
All right, wait, you just said like 10 different like fascinating things. I don't even know where to start. So if I were to stay in a hotel for like 5 days, and somebody like you walks in the 6th day, you'd be able to take like a biological DNA sample and determine who was there.
Absolutely, yeah. In fact, we did a study once in Naperville where we had some of my students come in and do mock burglaries in homes, and we identified that it was possible to, in a very Hercule Poirot, Agatha Christie kind of way, identify which burglar had burgled which home, even if they were wearing gloves, right? So just by the microbial signature that they shed from their body, from their breath, from their skin, when they moved around the home, even after only being in the home for 20 minutes. So it's possible to pick up that signature. It's not very good in a criminal case, though, because I exemplify the idea of Hercule Poirot from Agatha Christie, right? At the end of the story, he would always get the 5 people who may have done it in a room, and then through a period of deduction, figure out which one and tell the audience which one who done it, right? We don't have that real sophistication, right? I can tell you if I've got 5 people to choose from, I can tell you which one was in that space. But if I have 100,000 people in a city, I couldn't tell you which one burgled the home. So we did that work for the National Institutes of Justice to almost disprove the utility of microbial signature analysis in criminal court cases, because there were actually criminal cases out there that were trying to use that technology to indict people and prosecute them. And I was pretty sure you could not do that beyond a shadow of doubt. So we do like to have technologies put in place and test them rigorously to ensure that they are being used fairly and equitably in our society.
All right, so that's fascinating. Now, if I'm the type of person that goes into I'm going back to the hotel room, and I'm paranoid that there's germs, and I don't even want to touch the remote, or what you're saying is that don't go ahead and touch the remote. It doesn't matter. There's shedding everywhere, and it's just accept it.
Yeah, I mean, being a microbial ecologist makes you not fear bathrooms anymore, right? For the most part, you're living in a microbial soup all the time. The air is full of bacteria, viruses, fungi, and we are constantly being bombarded from them. In fact, our immune system evolved to sense it, right? We can actually, when microbes land on your skin, be it your hand, your arm, your face, there are immune cells inside the skin which see biochemically some of those microbial signatures and keep a record of them. So you don't actually have to have the bacteria invade your body for your immune system to be able to see it. They can just be on your skin, and it keeps a record of them like the CIA would, right? Or the FBI, to keep track of the microbial exposures that you're receiving day to day. But then, of course, these microbes can also get inside your body, right? We inhale them into our lungs, into our respiratory system. Anyone that knows about SARS-CoV-2 knew that. So apparently, my AI friends really like that sentence. But so when we inhale them, they get inside our lungs, and our immune system sees them there. Or we consume them, they get inside our body, and our immune system sees them there. And what we found is that microbial exposure can have profound effects upon our health, everything from our metabolism and metabolic and cardiometabolic health, all the way through to our immune health, hormonal variants and fluctuations, even our neurological health.
I don't even know where to start. So how did you get interested in this part of science of the microbiome in the first place?
Arthur, I get bored really, really, really easily. And so I take on lots and lots of different tasks, and I read a lot. And this is back in, I was a microbial ecologist for the past 25 years, right? Born and trained. But the human microbiome in this research really came apart came to the fore in my research career when I was working at University of Chicago. Back in 2009, 2010, we started to examine how infections occur during surgery, right? And the overwhelming theory at the time was that the doctor or the hospital room was dirty in some way, and the doctor had infected the patient, or the hospital room had infected the patient, and that's where all of these surgical infections were coming from, despite evidence to the contrary in the most part, right? But it was the overwhelming theory that was purported, and people were getting sued because of this. We had another theory, me and the surgical team at Chicago, and they came to me in my office and said, we know you work on the microbiome in oceans and in animals and in plants and soils. Would you be interested in working on the microbiome in surgical theatre and in our patients? And I said, well, yeah, we can have a look. And we found that what happens is the food you eat in your life, it allows the colonization of your gut by certain types of bacteria, not at high levels, and they're not necessarily pathogenic at that time, but they're present there. And then when you go in for surgery, all the antibiotics you have to consume, all the physical insult of being cut open and having parts of your body removed, actually lead to these bacteria proliferating inside you and causing tissue damage, which can lead to them becoming the predominant form of infection. And these bugs that you find inside your body that do this during surgery, that cause these infections, are best promoted by eating a high saturated fat, high sugar diet, what we refer to as the standard American diet, or the SAD diet, which I think is particularly pertinent. But so what you eat was actually affecting your risk of developing surgical infection, and that really triggered my interest into multiple facets. So we started looking at it in autism, in depression, in anxiety, in cardiometabolic disease, in women's health diseases like cervical cancer, in the impact of the microbiome on transitionary health diseases in menopause, in multiple cancers throughout the body. We just went crazy with it, right? We can find microbial signatures throughout the body that can predict what cancer type you have and the stage, right? Even before you have it. We haven't managed to get many of these treatments into the clinic yet, but these things take a long time. We have to prove that they're effective, but it's incredibly exciting.
I don't know where to start.
You said that now 3 times, and yet you kept on starting.
I know, well, because there's the area, it's like the Wild West, where there's so many unknowns. I mean, the fact that how about explain when do you work on like a single project, or do you have multiple projects? Because it sounds like you're.
We have about 42 research projects ongoing. You can drop my my lab website into the chat for anybody on the audience. But it's Gilbert Lab at ucsd.edu. But the projects are multifaceted because we're able to actually work with our research teams from across the world, right? My research team has people working on oyster microbiomes and human health, looking at the microbiomes of coral reefs. We just did a fecal microbiome transplant study in dolphins to cure dolphin IBD. We work in pediatric diseases, in chronic diseases, in adult populations. We run one of the largest nutrition for precision health studies, where we're looking at food as medicine and trying to treat diseases before they happen. We work in soil health, trying to increase plant and crop productivity to put more carbon below ground so we can reverse climate change, or at least create resilient crop systems. The list goes on. And again, a lot of this is due to the fact that I get bored and switch my ideas quite quickly, and then work with the people in my lab to come up with new research strategies to identify ways to answer those questions. It's the best thing about being a scientist. If you have a question, it's my job to figure out a way to answer it. And that's super cool, right? I don't think any other job where I sit there and go, I wake up in the morning and think of an idea and think, well, let's figure out a way to answer that. And we can actually do it, right? We have the tools and we have the expertise, and I work with phenomenal people. So it does proliferate, sometimes out of control, but I absolutely love it.
I'm glad you're not a bored person. Otherwise, do you have it's probably hard to answer. Do you have a favorite study, or what are the more exciting studies? They're all exciting, obviously, but are there ones right now that you're like really intrigued of where it's going, or you're seeing some early results?
Yeah, a lot of them are due to my family, right? So we're currently working with a company called Bened Health, and I'm consulting for them on developing a new clinical trial for adults with autism. In fact, TEDx talk I gave was focused on trying to understand how the microbiome could be playing a role in autism and the quality of life of autistic children, right? Not trying to cure it, because it's not a disorder and it's not a disease, but it does have massive side effects which can affect quality of life, and we want to figure out those. So we now work with adult autistic populations. My son's about to become an adult. He'll be an adult in about a year. And we are asking those people what conditions, what health traits they would like to see improved in their life, what quality of life measures they would like to see improved. And it's interesting, some people say, I really would like to stop my aggressive outbursts when I'm talking to people. Or my son, I really would like to be able to talk to girls more. I think that's a common teenage boy problem, but he struggles with communication, so he'd like to be able to talk to people more effectively, right? Or I would really like to be able to explore other people's ways of seeing things, because I'm often stuck in my own head, or I get hyper focused, or I can't sleep properly, right? And a lot of these are common problems that we all have, but the autistic adults are also very interested in helping to alleviate. So we're working to try and identify strategies to help them, both probiotic strategies, nutritional strategies, as well as different forms of medication to identify combinations which can be effective in different populations. That to me is super exciting because it's very personal. But I have, again, like you said, it's very hard to pick a pet project because I get excited about every single one of these projects. We're currently working with a population with a wonderful professor, Philippa Godoy, in Puerto Rico, and she's examining how the microbial community in the vaginal cavity around the cervix alters how tissue damage occurs, and therefore can affect the impact of HPV virus, so the virus that causes cervical cancer, can affect the risk of cervical cancer development when you get infected with that virus. Now, if everybody was taking their HPV vaccines, this wouldn't be a problem, but many societies around the world are still vaccine shy in that area. So we're still seeing very high rates of cervical cancer in young women. And we really want to be able to figure out which women are at risk. So these microbial solutions could play a role in helping to improve that. And as a product of that study, we've also identified that the microbiome in the vagina can significantly associate with the chances of conceiving naturally, right, in after sexual intercourse. So the microbial community can be actually manipulated to a certain extent in what we're referring to as a vaginal microbiome transplant to actually improve the chances of conceiving during either natural sex or during IVF. So we're really, we every single time we ask a question, we find new ways to explore different avenues, and That means I've got to hire another graduate student or another postdoc and find more money. It's a disorder I have.
Is that in the microbiome area of study? Is that somewhat the norm now? Where it sounds like once you dig one rabbit hole, 100 more pop up, and it just keeps. Is that unique?
It is, but it's a very much a continuous diagram, right? If you work in one very, very small area, that always happens. That's just science. Every hypothesis you test and validate brings up more hypotheses, right? You are constantly asking questions and constantly trying to test those questions. But the beautiful thing I love about working in the microbiome space is there are bacteria everywhere, right? Everywhere, and they're incredibly diverse. And they've been on this planet for about 2.5 billion years longer than we have. So it's really their planet, and we're just hanging around, in the last few 100,000 years trying to figure out what to do. And so we can examine health of our planet and of our bodies, right, from the context of the microbial world. And when you look at it from a different lens, it's really interesting that you can find ways to manipulate the environment to improve health, right, to improve resilience, again, both in our bodies and in a mangrove swamp or a coral reef or a farmer's field, right? We can develop strategies by leveraging that microbial world and harnessing it to improve general health, what we call One Health.
It's interesting how you talk about manipulating the environment, because traditional Western medicine is all just develop another pill or another type of therapy. And it's kind of an interesting approach where instead of, and correct me if I'm wrong, because what I'm hearing is that instead of just going after a pill, which could be part of the solution, this environment manipulation sounds fascinating.
Yeah, and we are currently exploring ways to work with local communities, both Native American populations in our areas, as well as farmers, Western farmers and Hispanic farmers up and down the coast of California, to try and identify ways to use microbial biostimulants to improve below ground carbon accumulation so that they can start charging carbon credits and actually generate a secondary source of revenue above and beyond what they can make in their cropping products. We believe this can actually have significant financial and economic impacts upon those communities by providing them with a level of revenue which they wouldn't otherwise be able to get hold of, as well as creating solutions to help them reduce the use of nitrogen fertilizers, phosphate fertilizers, which can pollute the environment and are also massively carbon polluting, and create a more resilient crop in the face of climate change, where we have these booms of drought, long periods of drought and sudden amounts of rain, which are damaging for cropping systems. So we're trying to develop these strategies which could have global impact, not just at the face of the science in itself, but economic impact on local communities so that they can become more self-sustaining in a changing world. So this is a multifaceted problem. And because microbes are everywhere, we can use them to address these problems at a scale which is previously only been dreamt of.
Now, this is wild stuff. So in the farm example, how does one apply micro?
Well, we've developed this big 17-member consortium, just 17 species of bacteria, which pretty much encompass all of the metabolic functions that you would normally expect to be in a quote-unquote healthy soil, a soil that's rich in humics, has a lot of good carbon in it, and is highly productive for plants. And literally, we create a solution. We dip the plants in there before we plant them, right, to allow those bacteria to colonize the root of the plant. And then we add another fungus in there, what's called a mycorrhizal fungi, which can grow with the roots of the plant and the bacteria to create like a nutrient superhighway. And this allows all that good carbon that the plants fix by sucking CO2 out of the atmosphere, and they drive it down below ground through this fungal network into the microbial community, stimulating their growth and making those microbes produce lots of recalcitrant or hard to break down carbons, which then get trapped in the soil, locking it down there in a really solid way. But you spray it over crops, or place it in the soil, or mix it in when you're actually planting your crops, in multiple different ways. And this is becoming a big industry.
And there's no, it's not like a poison. I mean, you just Just dip it, spray it, and that's it? Or is it like
Well, we hope it's not a poison. If it is, then we're in big trouble. But what we're trying to do is actually work with the natural local community. So the beautiful thing about our strategy is we can isolate the same 17 functional guilds, if you will, do the same kind of metabolism anywhere in the world. So we have a network of communities in Africa, for example, in Ghana, South Africa, Zambia, Nigeria, Angola, the Gabon, and a number of other countries, where we're working with local farmers to actually set up fermentation suites in their local communities so that they can isolate these functional guilds from their local soils and then grow them up, which creates industry locally, and then use them on their farms. And what we've actually found is there's a nice parallel. We worked with a community leader, Amber Fife Johnson, up in Washington State, where we demonstrated that children that spend more time outside are metabolically healthier, and children that go to schools that spend more time outside, and what these so-called forest schools, show higher levels of metabolic health. Again, AI loves me. And also they show high levels of metabolic health. They show lower levels of obesity. They show higher functional neurological health and mental health scores. Right? We show that that's linked to the microbial diversity of the soil. So creating these soil health programs around the world can have profound benefits upon the people's health that are working in that soil, the children that are growing up with that soil. Soil is life. As one of my colleagues, Joe Handelsman, says, a world without soil is a world that dies, right? For us, the oceans will be okay, but the planet, the land beings will not, right? We need healthy soils in our environment, and our health is intrinsically linked to that.
So to try to simplify what you're saying, like for this farm example, and again, one of the 40 studies, you see a future where there's a farm in some area, any part of the world, where it's almost like sourdough bread, where you have you developed your fermentation culture for what works for your crops, and you can just take some of that, give it to somebody else, seed them, and then they can have the same. Does anybody control the big business? I'm going to bring in the big pharma. You have to explain your AI thing too, what's happening, but how have you approached who owns the rights, and how does that work? Or how do you see that working? Is that an issue, or is that?
Yeah, it's a big issue. In different countries have different strategies for dealing with biodiversity utility. We prefer to keep things in country. There are companies trying to focus on doing this, and I have financial relationships with some of those. There are EPA and USDA regulations that are put in place to ensure that these products do no harm. However, not a lot of organizations or companies are actually getting behind the idea of local production. We think local production is the key way to doing this, which is the reason it's still a research program, right? Not a commercial entity at this time, but we think it's highly efficacious. And if we can work towards that future, it can pay dividends, both for that local community and for the planet. One of the key things that we found is that applying these products means that the farmer has to use less fertilizer, which costs them less money. They can use less herbicides and pesticides, again, cost them less money. That has beneficial effects upon the community and the biodiversity in that environment, less pollution and less destruction of insects and local flora. And also, more importantly, the crops tend to have a higher yield. And even better, some of those crops that we've tested have a higher nutritional value, right? So it really is going back to using the natural world to make more resilient and more nutrient-rich crops. But it's not simple. I mean, I'm not touting this click your fingers and all the problems go away solution. We also need to start working at engineering crops through the standard ways we've been doing it for thousands of years, right? Crop selection, to select crops that grow, produce deep roots, and work with this microbial community. For the last 100 or so years, we've been selecting crops that need chemical nitrogen fertilizers to be functionally productive and active. We need to move away from that strategy. I would like to make a call for an improvement in the Farm Bill, which is coming up, and potentially in the next Farm Bill for the federal government, to reduce incentives and subsidies for the use of chemical fertilizers and move more towards sustainable farming practices and these new innovative solutions that could save our soils and save our planet, as well as make farmers wealthier in the process.
I mean, it sounds like common sense, but it's government.
Well, it's government and industry and capitalism, man. If we can harness this mechanism and it makes people more money, then it will become de rigueur, right? You cannot escape that practice. The same is true for our medical treatments, right? If I can make food more precise, if I can tell you what you should and shouldn't eat, so you have a list of things which you need to avoid, I can make that food more bioavailable and healthier from the farming practice. We have a double whammy, right? People can access healthier, cheaper food, but they can also know which foods to eat in order to improve their health. That will significantly reduce the costs of our into our federal government for Medicare and Medicaid, because more people will be healthier, less chronic diseases, and it will also significantly improve the economic productivity of our country, because people will be healthier, they'll be taking less sick days. This is a win-win situation, and it's all down to the smallest living organisms, which none of us can see with our eyes.
So, and I want to, but basically, there's some questions I want to start bringing in. And again, if you want to come on live, we have somebody we're going to try to bring on live. Jonathan, as soon as Richard comes in, let's bring him into the feed. What can the average citizen do to help to learn more about this or to help drive these initiatives? Is there anything that we could do or the audience could do?
We do have a crowd-funded research program we call American Gut, or the Microsetta Initiative, which will be launched soon. We're just waiting for IRB approval. That will allow people to donate money to have their microbiome sequenced using some of our new advanced techniques. All that data is made public so that people, clinical scientists like myself and researchers around the world can understand if the trends, the microbial associations they're seeing in their small data sets and populations, say in Finland or somewhere else in the world, are mirrored in much larger population studies. So those crowd-funded approaches are really highly effective, and using that mechanism since 2011, we took a break for the pandemic. We've sequenced over 35,000 people's microbiomes around the world, and this data again is all publicly available. It's used by commercial entities and by research entities, but it's highly effective for helping to push forward the future of research. And there are field trials ongoing. So if there are any agronomists or growers in the community that are interested in partnering up on these kinds of studies and think this might be the future of agronomy, they can contact me, and I'd be happy to talk to them. For medical practice, it's complicated, right? A lot of the techniques and approaches we're using take a little while to get into the traditional medical system. But eating healthier is always a good strategy, and that's really more fiber and eating more colored plants. I recommend people eat at least 30 different species of plants a week. Remember, you can't cabbages and broccoli and cauliflower are all one species, so they don't count. You got to go with a little bit more diversity. But eating 30 different species of vegetable a week, fruits and vegetables, is a highly effective way at helping to maintain your health.
That's a 30 different species. Oh, does French fries count as a vegetable?
It sounds difficult. It's really not. It's really not difficult.
Fascinating. All right. Yeah, this is really exciting stuff. I want to bring in a question. Dr. Linda Ulrich has a question. She says, a lunchbox. Oh, yeah, we can bring in. Here we go. I forgot we had that. Well, here's another. Sorry, Jonathan's going to bring this question. How do we know if the gut biome is impacted by the microplastics? Oh, that's a great question.
Yeah, so far, we've seen some data to suggest it's having an impact on the abundance of microplastics, maybe altering the microbial diversity of certain animal species. But that's because we can do that test in the lab, right? We can look at the gut microbiome of rats exposed to microplastics versus rats that aren't. In humans, it's virtually impossible to find people that aren't exposed to microplastics, right? I mean, it literally is in pretty much our entire water system and most of our foods, right? It's so prolific, it's almost systemic now. And so and we don't have a lot of data from the quote unquote before times, right? When people weren't exposed to extensive amounts of microplastics. So it's very hard to make that assessment. And if we look at populations that aren't exposed to microplastics, like for example, Meri Indian tribes in the Amazon jungle that have lived in remote and protected communities, their lifestyle is so fundamentally different, it's virtually impossible to tell if it's the microplastics changing us or the fact that we live in such urbanized and processed food rich environments, which are heavily polluted. So I would argue it does, but we can't tell what impact it's having on our gut microbiome, and we don't know what impact it's having on our health.
And John, okay, oh great, we're gonna bring in and actually another TEDx Naperville speaker alumni. Nice to see you, Richard. He spoke 10, 12 years ago.
Yeah,
long time no see.
Yeah, hi Jack, how are you? Long time no see. I'm Art. It's good to see you again.
Yeah, go ahead with your question, Richard.
I knew about all the work you were doing on the gut microbiome, obviously, Jack. And I guess one of the things, because you're looking at that microbiome on the space station, what are you thinking about the fact, we're going to go to the moon, we're going to go to Mars? What microbes are absolutely essential for us to take with us? I know we're going to take a lot on us, but what do we need to take with us to make sure that we don't just kind of croak while we're out there?
That's a really good point, actually. In fact, we working with NASA and with several other groups, we've formed a company called BiomeSense, which we actually launched out of University of Chicago, and it's being scaled up now for clinical trials on Earth. But the device we're hoping to adapt to be useful for lunar and Mars-based missions, where we can place a microbiome sensing platform on the planet, right? So any astronaut or anybody working in that environment, I guess they're all astronauts at that point, can process and analyze samples of their microbiome from their bodies or from the lunar environment or from the Mars environment or from surfaces on the planet, right? They don't have to lift off materials and bring them back in very expensive payloads back to Earth. They can do everything on planet or on planetoid if you're talking about the moon. And that's a really important strategy because that allows us to do on-site surveys and on-site sensing to determine if people are losing certain microorganisms due to changes in nutrition, due to changes in lifestyle, due to changes in exposure. And if you're there for, say, 9-10 months in this highly isolated, highly filtered environment, what impact that could be having. And if we can then, if we determine that, we might be able to determine which organisms we need to bring with us. However, we have had discussions, right? Number one, you definitely need to bring soil bacteria. If you're going to be growing anything up there, you need those in reserve to make sure. If anyone's ever watched The Martian, he uses his own fecal matter to make a microbial soup out of soil to grow potatoes. That's a given, right? We need to be sure that we're bringing soil bacteria. But we can also bring collections of gut bacteria that allow for what I refer to as a repopulation of your gut tract, right? So if you do lose microbial health, we can restore it with a fecal microbiome transplant. We can do that in the form of pills now that contain these bacteria that you swallow. They pass the stomach and can repopulate the gastrointestinal tract. And that's probably the most effective way to treat gastrointestinal disease in these remote locations. And so we would be allowing our astronauts to travel with these new medications.
Yeah, I still want that for my two kids. I remember when you met my two kids, I said I'd sell them to you for medical experiments.
Yes, you didn't have enough money for it though.
Thanks, Art. It's good to see you again, Jack.
Thanks, Richard.
Yeah, thanks, Richard. So you bring an interesting point with these, like with diseases and with digestive, ailments, Crohn's disease. What can somebody do that's maybe watching this now that's just understanding this? Oh my gosh, there's actually solutions with these fecal transplants. What do you recommend they do since they're not so plugged in as you are? Because their doctor, well, and it's a two-part question. Do you think their doctors is this mainstream enough where most doctors are aware of these treatments?
Yeah, so the only treatments that are currently FDA approved, be they fecal microbiome transplants or several new precision microbiome tools that have been developed and commercially released and FDA approved, are for the treatment of C. diff infections. You may have heard of C. diff. It's a bacteria called Clostridioides difficile, and it causes a recurrent infection. Our first stage, if you come up with C. diff, we all get bloating and severe diarrhea. It can lead to malnutrition and severe illness, is to give you antibiotics. But that only works in about 60% of the cases. 40% of people have what we refer as recurrent C. difficile, and 20% of those will have severe recurrent C. difficile, which can lead to death. So we found ways of providing these fecal microbiome transplants to treat those participants, and they are highly, highly effective, 90% efficacy. So that can be incredibly powerful as a tool. And the doctors, if your doctor's worth their salt, will know about those techniques, and if you have that diagnosis, will be able to put you in contact with clinical teams at local hospitals, which will be able to provide it. For other conditions, it's variable in its success rate. So, for example, for Crohn's disease, colitis, and IBD even, some people it's highly successful, other people it's not, which means that it's hard for the FDA to make an approval on a blanket scale. And we're not entirely sure what makes some people susceptible to treatment efficacy and others not, right? Why do some people get better and others don't? And so until we know that, we cannot approve it at that kind of scale. So there are other strategies, right? There are probiotic strategies which seem to work reasonably well in some people, and those aren't FDA regulated. You can buy most probiotics over the counter, and so those are what people are turning to. And your doctor should be able to recommend particular types of probiotics which can be purchased that could be effective in treating that, because there are double-blind, placebo-controlled, randomized clinical trials, a gold standard way of demonstrating efficacy for these treatments that have been done on those, and they have demonstrated success. Doesn't mean they work, but it means that they have a higher likelihood than other strategies. So we are working our way to making sure these treatments are available, but we're not quite there yet.
You brought up a good question when it comes to probiotics. Since there's no FDA approval, and you see it everywhere, and when Costco has like 2 or 3 different probiotics, that it's kind of hit mainstream. Are there any guidelines that people should have when they're looking at probiotics?
I'll wager that Costco has a lot more than 2 or 3. But
really?
Yeah, I mean, it's difficult, right? I would argue the vast majority of people, and I think this was made very, very clear by the SARS-CoV-2 pandemic, it's very hard for somebody who doesn't have clinical training to assess a scientific paper which demonstrates the results of a double-blind, placebo-controlled, randomized clinical trial, right? You can say that it's that, but people can get a paper published in a really, really nefarious for-profit journal and say it's peer-reviewed, when in fact it's a terrible study and should never have been published, right? And this is the problem with our scientific publishing world today. I suggest only looking at papers that are in reputable scientific journals. And again, for the common man, it's very hard for most people to understand what a reputable scientific journal is. So I would recommend always talking to your doctor about what probiotics they would recommend. They may not still be as clued in as someone like myself on what was an effective or an appropriate remedy for a particular condition, but they will be a lot better than just picking a random one off the shelf and hoping for the best, right? And a lot better than listening to your Facebook group, which probably doesn't know the answer that you're looking for.
Yeah, well said. The circle back to something you mentioned, that there's going to be.
Yes, I am, Hazel. Hazel's asking important questions.
Oh.
No, I'm also in a punk band called Punk Is Dad, which is probably my most important contribution to the world outside of my children. We really do try and rock the punk music scene in San Diego with our middle-aged tones and rockouts.
And what punk bands are you influenced by?
The Ramones,
right.
And definitely Ramones, definitely Green Day, which I call new punk.
Yeah,
the Sex Pistols, absolutely.
All right.
Even I call Pixies as a punk retro. So I think there's opportunities there. We're pretty eclectic.
All right, I like that. Well, all right. Your cool factor just went up a couple notches. Okay.
That was all it took. That's good.
The circle back, you mentioned before that there's going to be this initiative coming out soon, where how people can get more involved. Is that going to be announced? Is that something that? How can somebody get that? Again, when I hear about it, I'll announce it to our community too.
Yeah, but you can also follow me on Facebook or X or Blue Sky or LinkedIn. I'm on all those platforms, and I will make announcements on those platforms when these techniques and studies are available.
And Jonathan, while we're talking, he's going to drop that as a window so people can see that, because it's interesting how, I don't know if this, I have to ask an AI question, but it sounds like the research is growing exponentially, kind of like how AI is. And that brings us to another question, which I hate to bring up AI because that's the buzzword.
Yeah.
But how is AI affecting the research that you're doing with the microbiome?
It's absolutely essential. We couldn't do the kind of research at the scale we do it at without using machine learning approaches, which are an essential part of artificial intelligence. For us, it's so important because the sheer volume of data we generate. So one study that people can get involved with now, if they're willing to go through the rigmarole, is our Nutrition for Precision Health program, which has in Chicagoland recruiting centers in University of Chicago, Northwestern, University Medical Center sites. And you can go to Nutrition for Precision Health, type that into Google, and you'll find ways to find a local recruiting center. It's an All of Us project run by the All of Us clinical program, which is a massive US study that aims to sequence 1 million people's genomes. And in this Nutrition Precision Health study, we are testing 10,000 people on different diets to determine how they physiologically respond to those diets. And then we measure their microbiome, we measure their blood chemistry, we measure their, how many steps they're taking, their psychological evaluation, pretty much every physical test you can possibly apply to a human being. And then we use that information to determine which of these variables. Is it microbiome? Is it, blood H1A? Is it A1C? Sorry. Is it your cholesterol level? Is it your glucose level? Is it your latest neurological score? Which of those variables best predicts how you respond to food, so that we can make better predictions about which food will be better for you? And that's 10,000 people. That generates petabytes of data, right? And there isn't a single graduate student or postdoc team alive which has the bandwidth and the time to process and analyze it all and look for the traits that we need to find. It would take a decade or more. So we use artificial intelligence to sort through that data and look through the 200 different data streams across 10,000 people and hunt down the traits which are best predictive of how individuals respond to their diet, and to find which diet is healthier for them. That, to me, is the pure power of AI. It's significantly improving our ability to do tasks faster by aiding us in that process.
So I'm so glad that you finally talked about AI as a significant benefit that's crucial versus all these doomsayers. They're having different discussions where the AI discussion should be more about an alignment with what you're talking about. How can it really be beneficial? And it's actually critical. And again, and Jonathan, if you want to pop up while we're talking the link to where people can follow Jack. As we're coming to a close, I got so many more questions. Is there anything that you can share, like any early signs? I don't even know how to put the question properly, but any early indicators of something that's really exciting that you're seeing, that maybe it's not even remotely proven, but you're like, that's really fascinating, that you could share with us?
Yeah, absolutely. We found something really cool recently. So we've isolated several bacteria which were absent in people with major depressive disorder. And these bacteria are relatively common in the US population, but in people with major depressive disorder, they're completely absent. And these bacteria, alive or dead, have a protein on the surface of their cell, which when we reintroduce it into an animal, we haven't done it into humans yet, but we isolated it from humans, healthy humans. When we introduce it into an animal, this protein activates a particular pathway in the gut interface, which sends a signal to the hippocampus in the brain, right, that drives down through our pituitary gland into our adrenal gland, right? And that adrenal gland then shuts down cortisol level production. Why is that important? Well, one of the key problems that we have in our society is that the way people eat and the way we live our lives causes elevated levels of inflammation. And the inflammation actually stems from how the food we eat and our lifestyle affects what bacteria can grow inside our intestine. If you eat a high-fat, high-sugary diet and you don't take a lot of exercise and you live in a polluted environment, you actually have a microbiome in your gut which causes inflammation. And that inflammation triggers your adrenal gland to release cortisol into your bloodstream. So you end up with this very elevated level of inflammation. And that's of stress, because cortisol causes stress, right? And if you have an elevated level of stress, you need to reduce it. You need to reduce that cortisol level in order to drive down stress and drive down your chance of developing depression. In people who are genetically predisposed to depression, this lifestyle triggers this cortisol level and leads to an onset of the physical symptoms and psychological symptoms of depression. We found that this one bacteria, when we reintroduce it, can shut that system down, even in the presence of a high-fat, high-sugar diet. And that action can actually completely, in our animal models, can completely recover an animal from a depressive-like symptom state. And an efficacy that's has the same as taking ketamine. So if you know, ketamine is now a powerful antidepressant that people are using. It's also a horse tranquilizer. Interesting in the way we find our drugs, right? But people are taking ketamine as a powerful antidepressant. It's highly effective, but it's also a drug, right? It's a drug that interferes with how your brain works. We found a bacteria that's present in the guts of healthy people that when we reintroduce it to people who have major depressive disorder could affect their chances of recovery. So we really want to power through that. Depression is a major threat to our society. Anxiety and depression affect our children and affect our working stock. We have a massive economic impact of depression in the US. To maintain our economic prowess throughout the world, we need to really fix that problem, as well as to make sure people are mentally healthy. So we are focused on trying to get these what are almost a dead probiotic, right, into clinical trials so we can demonstrate efficacy in humans.
Man, that's wild. I mean, that's just one of the many wild things that you're mentioning.
Well, I've got one more. If you've got like 5 seconds.
Yeah, come on. I'll be here all night. So
yeah, we found a bacteria though that can actually treat a chronic obstructive pulmonary disorder, so emphysema, right? This bacteria, when we introduce it into the lungs of mice which have had emphysema triggered in their lung, actually reverses the damage that emphysema causes to the lung tissue and allows the animal to regain almost complete lung function. So we think we can use this. We need to put it into a human trial as a puffer, right? So you just puff these bacteria into your lung like you would as an asthma treatment. And the bacteria colonizes the lung environment, releases chemicals which improve the immune system and therefore improve the physical integrity of the tissue and cause the tissue to regenerate. That would be kick-ass.
This is wild stuff. Again, this area, to bring things to a close, this area of study is just so fascinating, and it's just amazing. I can see why you're so excited about it. I mean, every single thing, this microbiome touches everything we do, and it looks like, to kind of rehash, if you, Jonathan, you pull up the follow, Jack, if you want to.
So let me just. Sorry, I'm going to chime in because that's the beauty of being the producer. I can jump in. There are 2 or 3 other questions, Jack. Maybe what we can do, because there's some pretty interesting. I mean, there's 2 or 3 kind of interesting ones that you've touched on pieces. Maybe if afterwards you can go into the comment stream and maybe reply to those questions, that would be amazing.
Yep.
There's an autoimmune one, there's an epigenetics one, and there's a couple of other ones. So, and I can send you them on email, and then maybe you can just jump in and kind of respond to them. That would be fantastic. And yeah, I'll add the other stuff in.
Yeah, and thanks, Jack. Thank you. We want to be sensitive to your time. Thank you so much for doing this. And a little history. Jack did a salon for us pre-pandemic at a restaurant, Mason Sabika, and Jack's so passionate about this. They serve the food. I love sharing the story. There's like 20 people. They serve the food. Jack stood up, talked for like an hour and a half, 2 hours straight. Didn't even touch your for your food.
I didn't get any food.
It was just it's fascinating, and I thank you for sharing that nutrition for precision health. That's something that actually people can. I'm going to check that out. That we can actually start getting more involved to get volunteers if people want to do that. I think Russ Rendu said that he actually was part of that.
Yeah, I think you can be paid $6,000 as well for joining that clinical study, but it is quite intense. So, be prepared to be prodded and poked.
Now I'm turned off. Now you got mad. I was all excited. I'm like, but definitely
It's all for science. All for science.
I want people to follow what you're doing. And I know you wrote a book, and we can, I think Michelle can share she shared a link in there on Dirt. I think it was called Get Dirty.
Dirt is good.
Dirt is good.
Yeah, it's a guide for young parents more than anything, but it's got a lot of information there on probiotics. So if you're interested in which probiotics are useful for treating which diseases, it's a really good book to buy because we did a deep dive in an accessible way.
Definitely. And I want to make sure Jonathan shared how to contact you, how to follow you. On behalf of the TEDx Naperville community, thank you so much for taking the time. Because I know that you're with all those experiments, the fact that you gave us an hour is precious, and we thank you so much for it.
Actually, 2 minutes late for another meeting with the local community tribes. So
please go, and thank you so much, Jack. And we'll be in touch, and we'll find a way to share more of your information with our community. But thank you so much.
Cheers, I appreciate it. Take care.
Drop off. You can drop off, and to close out, you can see why Dr. Jack Gilbert is such a great guest. And it's a funny story. When I first met him, he was working at Argonne National Laboratory, and I met him for lunch and got to sit in his office. And he started explaining the microbiome information. And at one point, he took a typical Brit. He had British tea, and he was stirring it with a pair of scissors that were lying on his desk. And he was on his knees, like writing on this a whiteboard that had fallen on the floor. And he did not stop talking. And I was just like, this guy's amazing. So it was a fun experience. And I'm glad we all got to see that today. That's the close of the show. Put your comments in the, thanks, Jonathan. Put your comments in the YouTube chat, and hopefully Jack can come back and make some responses. I think that Jack might be somebody who we want to get back on again, just because it's such a fascinating area. He could take one of his 40 studies and just do a whole session on that. But thanks for being part of this. Thanks for all the comments. Thanks, Richard, for coming in and talking. Thanks, Jonathan, if you want to pop in and say any final words. Thanks for Jonathan from Nashville, our Nashville, Tennessee group. But definitely, if you want more salons, let us know. If you want to be more, if you want to help produce these events or be part of these events, again, go to our website, TEDxNaperville.com, or participate. We need volunteers. We definitely need a volunteer coordinator. That's our initial thing, and we need partners. So if you're a company or you know somebody who wouldn't mind helping finance what we're doing here, because we want to do more salons. We want to do more salons in person now that we're post COVID. And the one with Jack was great because we did it Maison Sabika. We had a nice dinner, wine. And it was Jack with a small group of like 15 people, and he just talked for like 2 hours straight, and it was wonderful. So that's it. Thank you, Jonathan. Thank you, Michelle.
Thank you, guys.
Thank you to all the team members, like Kristen and Liz, who are on our team that you're not seeing here today. But thanks for all the guests, and thank you so much. And look for an announcement coming up soon for the April 25th live event, where we're going to showcase some talks from TED with 2 live AI speakers and a nice spread of food from Nokia. Thanks, everybody. That's signing off.
Human beings, we're wired to be connected. From birth, we look